We want to find t, n, and b for this planar curve. So we'll calculate t. To find t, we take the velocity divided by the speed. So the velocity, let's see, this is 3 root 2 over 2 times sine t. So the derivative of sine t is cosine t. So we get 3 root 2 over 2 cosine t. And the y function is the same as the x component too. So the derivative is again 3 root 2 over 2 cosine t. And the derivative of cosine is minus sine, so minus 3 sine t. We need to divide all that by the length of this vector, and the length of this vector, this is basically 3 over root 2, so if we square it we get 9 over 2. So we have 9 halves the cosine squared of t, and another 9 halves cosine squared of t, and plus 9 sine squared of t. Now 9 halves and 9 halves cosine squared would make a total of 9 cosine squared. 9 cosine squared plus 9 sine squared, that would make 9, and the square root of 9 is 3. So our unit tangent turns out to be r prime divided by 3. So we're going to get root 2 over 2 cosine t, and another root 2 over 2 cosine t, and then finally 3 sine t divided by 3 would be minus sine t. So that's our unit tangent. Now to get our unit normal, we can take t prime of t and divide by the length of t prime of t. And let's see, t prime of t would be minus root 2 over 2 sine t minus root 2 over 2 sine t, and the derivative of minus sine is minus cosine, so minus cosine t. And if we look at the length here, if you square root 2 over 2, you get a half, so we have 1/2 sine squared, and another 1/2 sine squared, and then a cosine squared. Now a half a sine squared and another half a sine squared make a whole sine squared, and a whole sine squared plus a cosine squared makes 1, and the square root of 1 is 1. So the length of t prime in this case actually was 1. So we have, you get root 2 over 2 sine t, negative root 2 over 2 sine t, and negative cosine t for our unit normal. Finally, we can find our binormal by taking t cross n, and we'll just take the determinant here. We have root 2 over 2 cosine t, and root 2 over 2 cosine t, and finally minus sine t. And then for our unit normal, we have minus root 2 over 2 sine t, minus root 2 over 2 sine t, and minus cosine t. So when we do the cross product, we get I times negative root 2 over 2 cosine squared, so negative root 2 over 2 cosine squared t, minus root 2 over 2 sine squared t, and then for the j, we get a plus sine squared and a plus cosine squared. So we have root 2 over 2 sine squared of t, and root 2 over 2 cosine squared of t. And then finally for our k component, we get negative root, let's see, negative 1/2 sine cosine minus minus sine cosine. So for our k component, we actually get 0 there for our binormal. Now we can simplify this a little bit because we have the same number, negative root 2 over 2 times cosine squared n by sine squared. So we factor that out, we have negative root 2 over 2 times cosine squared plus sine squared, which is 1. And this makes root 2 over 2 and 0. Now, we should probably check this. When we do a cross product, we should check and make sure our binomial is actually perpendicular to the two original vectors. So our binormal, is perpendicular to our two original vectors. So we get here, if we multiply this, we're going to get 2 over 4, so that's 1/2 sine and a minus 1/2 sine, and 0. So that makes 0. And check the dot product of b with t, and we get minus 1/2 cosine and plus 1/2 cosine and 0. So this b is perpendicular to both n and t. So that's a good indication that we've done the cross product at least correctly. So we've got our unit tangent, our unit normal, and our binormal.